All right, so these are the reteach notes for today over calculating speed and distance versus time graphs. So first, how do we calculate speed? Speed is how fast an object moves, and it's calculated by taking the distance an object travels divided by the time it takes to travel that distance. Or the formula, speed equals distance divided by time, or d divided by t. So when you are reading the math problem, Carla ran 35 miles in 10 hours. How fast was Carla's average speed? You're looking for S, D, and T. So we'll talk about the units for speed momentarily, but for distance, it could be units like miles, meters, kilometers. These are all examples of units for distance. For time, you're going to maybe see seconds, minutes, hours, etc. So Carla ran 35 miles in 10 hours. How fast was Carla's average speed? So 35 miles, miles is distance, so this is D. Hours is time, so that's T. And they want us to calculate speed. So we don't need to do any rearranging with this formula, we just plug our numbers in. So S is equal to D divided by T is equal to 35 divided by 10. And when you get a calculator and do 35 divided by 10, 3.5. Now, you always have to have a unit on your answer. You can't just have the number. So sometimes they'll give you the right number, but they'll give you different units. So you have to keep an eye on that. So they gave us miles and they gave us hours. So it was 35 miles divided by 10 hours. So we divided the numbers. So that leaves us with our unit, which is miles per or divided by hours. On a graph, because you may be asked to calculate speed from either a word problem or from a graph, all you need to do is calculate the slope, the way that you would calculate a slope in your math class. However, you can tell the slope or the speed of a line comparatively just by looking at how steep or how not steep a line is. So a large slope with a much steeper line is going to be faster. It's going to have a faster speed, where a small slope with a lower line or a less steep line is going to have a slower speed. To calculate the speed of an object from the graph, you are going to use the slope formula. I always just use rise over run because I think it's a little bit easier than trying to do like y2 minus y1, x2 minus x1. So what I do is I go to my graph and I take two easy to find points on my graph. So a place where it actually intersects with your graph lines. And then I like to draw myself my little triangle. So my rise is, on this one, it's already marked for me. So going over from my point to the y-axis, I see that it's 8. So my rise is equal to 8. And my run on my y-axis is 3. So we have slope equals rise over run equals 8 divided by 3. And now for units, Notice that on this axis they gave us meters, and on this axis they gave us seconds. So it's meters divided by second. So 8 divided by 3. 8 divided by 3 is 2.66 repeats. Speed for this line. You may also be asked about the motion of the object based on the way that the graph looks. So this should be pretty self-explanatory. You just have to memorize these. So if the line is straight and going up, then that means that it's moving at a constant speed going forwards. So, because this is charting its distance away from some sort of starting point. So this would be where it started, and it's moving away from the starting point. You don't need to write that down. At a constant speed because it's a straight line. If it's a flat line, so it has a slope of 0, then that means that it's not moving or stationary. So not moving or stationary. If the line looks like a U going upwards, so half of a parabola, that means that it is speeding up or increasing speed. If it looks like a parabola on its side, so like a sideways U, that means that it is slowing down or decreasing speed. If it looks like a straight line, but it's pointing downwards, that means that its distance away from the starting point is decreasing. So we'll say that this is constant speed backwards. So looking at this graph here, A is referring to this line. So we see that it's a straight line, so it's constant speed forwards. B is half of a U going upwards, so that's increasing speed. C is a flat line with no slope, so that's not moving. D is another one of those straight lines going up. So constant speed forwards. And note that D has a less steep slope than A is. So A is going faster than D. And then E, it's constant speed again, but this time it's going backwards.